Next periodicity is about electronegativity in a periodic table. What is electronegativity? The ability of an atom to attract the shared pair of electron towards itself in a molecule is called as the electronegativity. Bonds are formed, as we know, by the sharing of the electron. When the shared pair of electron is attracted more by one atom as compared to the other atom, which shows that atom which is pulling more electron towards the pair of electron towards itself having a more electronegativity as compared to the atom which weak to pull the electron towards itself. Here you can see, as we know, the bonds formed by the sharing of electron. This is basically the example of ionic compound. In an ionic compound, there is complete transfer of electron. As we know, metals always donate electrons because of electropositive nature, and non-metals as chlorine always gain electrons because of the electronegative nature. So, while there is a bonding between sodium and chlorine to make sodium chloride common salt, sodium will lose its electrons because of low electronegativity, low ability to attract the shared pair of electron towards itself as compared to chlorine. Chlorine having an ability to attract the shared pair of electron towards itself. So chlorine having a strong pull as compared to sodium, and sodium having a weak pull to keep the electrons itself. That's why sodium loses electron and becomes positive ion, and due to electronegative nature of chlorine take one electron and become negative ion, chloride ion. The highest value of electronegativity in periodic table is for fluorine, and the lowest electronegative value is for francium. Francium is the element of the first group at the bottom in the seventh period. So that's why francium having a very low value of electronegativity. Fluorine is the first element of the halogen on the right side of the periodic table and having a very high value of electronegativity. You will better understand when I will show you the periodic table. Here you can see electronegativity increases along the period and decreases down the group. Why it decreases down the group and increases along the period? The reason is same as we said in electron affinity and in ionization energy, that along the period atomic size decreases. As we know, lithium having two shells, first shell having 2 electrons and the second shell having 1 electron. If we are moving along the period till the, for example, fluorine having 2 shells, first shell having 2 electrons and the second shell having 7 electrons. 1, 2, 3, 4, 5, 6, 7. So you can see here the number of electrons are increasing. Due to that, the atomic size decreases because the attraction towards the nucleus or the nucleus attraction for the electrons increases. Due to that attraction towards the nucleus, the atomic size decreases. Due to the decrease of the atomic size, nucleus feel more attraction towards the shared pair of electron. As we said in electron affinity, the attraction for incoming electrons increases to make an ion. But in electronegativity, the ion is not formed. The sharing between two atoms takes place, but the electron pair remains more time for towards the more electronegative atom. For example, there is a sharing between hydrogen and chloride. This is hydrochloric acid. They share one electron. One electron is shared by chlorine and one electron is shared by hydrogen. So due to electronegative nature of chlorine, this shared pair of electron will be towards chlorine atom as compared to hydrogen atom because of the more electronegativity of chlorine. As I said, electronegativity is the ability of an atom to attract the shared pair of electron towards itself. That's why this pair of electrons will remain for more time towards this chlorine atom. Instead of this, down the group, the number of shells are increasing. Due to the increase of the number of shells, the shielding effect is increasing. Attraction for the outermost shell towards the nucleus decreases. Due to that decrease in attraction for the outermost shells, the nucleus feel less attraction towards the incoming shared pair of electron, towards the shared pair of electron. So that's why electronegativity decreases down the group. There is a little bit difference in electronegativity in transition metals. This is a d block and the elements are called as transition elements here, metals. While we are talking about with the addition of this transition element, so you can see here the trend of increase in electronegativity from francium towards the fluorine. Fluorine is the highly electronegative atom and francium is the highly electropositive atom and lowest electronegative atom. Similarly, fluorine is the lowest electropositive atom. So the trend of electronegativity increases when you move from francium to fluorine, making this diagonal. Because there is change in the trend of electronegativity in transition metals. Here you can see the value of electronegativity of S block elements and some P block elements. Fluorine having the highest value of electronegativity, that is 4. Other than 4, there is no value of electronegativity. The highest value of electronegativity is 4 and the lowest value of electronegativity is 0.7. That is for francium and the highest value of electronegativity is 4. That is for fluorine. You can see here the electronegative value for oxygen is 3.5. The electronegativity value for nitrogen is 3. The electronegativity value for carbon is 2.5 and for boron it is 2.0. Lithium having the value of electronegativity, that is 1, which shows it is electropositive. Sodium having 0.9, it is more electropositive. Potassium having electronegativity value, that is 0.8, which shows potassium is more electropositive than sodium. Rubidium having the same electronegativity value, that is 0.8. Cesium also having a electronegative negative value, that is 0.8. So these are some values of electronegativity for some atoms.